So for the finding G part of the lab, there's going to be two methods that we're going to use to find G.
Okay.
All right. Way number one involves, let's do this. We're going to start with actually in either case, we'll start with a free body diagram. So we have free body diagram for the entire system, right? Not just mass 1, not just mass 2, not just all. And remember, for an Atwood machine, we simplify that into right and left. You can go with your setup as terms of right and left. For example, on mine just now, the heavier side, the M1 side, was over here, and the M2 side was over here. Doesn't matter, right and left, right? Doesn't matter. It might be easier to do it this way regardless, because you'll have a situation where to the right will be more positive, and will be bigger. Positive makes it easier. So you have M1G is pulling to the right. Pulling to the left is the smaller M2G. What is the amount of mass that we're talking about here? Is it just M1, just M2, or M3? It turns out just M3, it's all of them, right? It's the total mass gets accelerated. So we keep that in mind because that's going to be important. So what we end up with when you do the force analysis, you have net force equals MA. Remember, the M here is that total mass. Whereas when we look at net force is equal to M1G minus M2G. It's another way to look at net force. It comes from the free body diagram. With this direction as the positive direction. So, setting those two equal to each other and replacing total mass with all that. So I have M1 plus M2 plus M3 equals M1G minus M2G. Oh, there's an A in there. All right. See if well, for now, I'm going to put the A here because it's just more convenient to do that. So I forgot my A there. Now, in this lab, what we're looking for is G, right? We're pretending we don't know what G is and seeing if we can get close. So I'm actually going to solve this for G. And what that's going to look like, it involves factoring, or as I like to call it, reverse distribution. I'm going to pull a G outside of this side over here. So for example, it's going to be 1 plus 2 plus M3 times A, putting the A back on the right because it's more comfortable for me there. And then we're going to factor out the G. G times M1 minus M2. If I factor out the G, it isn't with those anymore. It's on the outside. So I'm going to then divide both sides by M1 minus M2, that quantity. So all this over here goes M1 minus M2. We'll keep it there for a second, because I remember this step, because we're actually going to go back and we're going to look at it a different way in a second. But we just solve it for G then. G comes out to be, I'm going to put the A on the other side now. I just can't make up my mind. M1 plus M2 plus M3. So it's going to be A times that all over M1 minus M2. Another way to write that is to put the A right there and just say M1 plus M2 plus M3 over M1 minus M2. Now what I want you to notice is this, the sum of the masses, is always going to be bigger than this. Right? You're subtracting two masses, And then you have those two added, which has to be bigger, plus more. So this number has to be, this number right here, this entire number, right, has to be bigger than 1, correct? It's a number, think about it, that when I multiply times whatever acceleration I measured, should give me 9.8 in a perfect world. So one way to find G now at this point is to set up a table where you take, for example, for every trial, tell it to take, put in that mess. M1 plus M2 plus M3 over M1 minus M2. Take that number, whatever it is, multiply it times, so trial, whoops, let me move this over here, my fault. This is a little messy. It's going to be trial 1. And then we're going to take this mess right here. Ooh, I got this all over the place. Hold on. This is just a mess, but we got it. No. Pause. There. Trial number 1. I need this quantity, whatever it is, from trial 1, and then the acceleration from trial 1. Multiply the two of them, that should give me G for trial 1. I do that for every trial. Theoretically, I get 10 values for G. I find their average, and I possibly find their standard deviation to see how far off it is, but we'll talk about that in a second when we do the Excel part. So I will show you, by the way, in another screencast, how to do this with Excel. It's very easy. You probably could already do it. But I'll show you how to do that and how to find the standard deviation and how to set this up. Now, there's another way to do this, though, that actually, in my opinion, is cooler and, in my experience with doing this lab once, actually gave me a better value. I don't know if that's coincidence or not. So let's look at this step. There was a point when we had, let's see, it looked like A times M1 plus M2 plus M3 equals G times M1 minus M2. So if you recall, we had that point a little bit ago. What I want to do now is I actually want to solve for A. You'll see why in a moment. So I'm going to divide both sides by this mess. That's going to give me A equals G times M1 minus M2 divided by M1 plus M2 plus M3. Of course, for every trial, don't forget, this quantity right here is just a number we could find, because we have M1, M2, and M3 all set and ready to go. So for each trial has its own value for that, correct? Each trial has its own value for A. We bring back an oldie but a goodie. So you recall what this looks like. Y equals mx plus, well, b. Right? The equation for a line. I don't care about b because if there's no mass, nothing's accelerating, right? In this case, it means we're not doing anything. So 0, or the mass difference would have to be 0, so that's a pointless thing. So for us, we know b is not an issue. Given the way I've written it right now, what is playing the role of acceleration? That's our y, right? And what's x? What's this garbage, right? Is the x. What's our slope, the way I've written it? Should be g, right? So here's the deal. We're going to plot, using Excel, we're going to build a table that has A as my x for every trial, M1 minus M2 over, I'm going to say M total, please, so it's quicker to write. I'm going to do that for every trial. So a bunch of x's, and these being a bunch of y's. I'm going to ask Excel to find me a best fit line. And when it does, I'm going to look at the slope of that line, because that slope better be close to 9.8. So it's another way to sort of average the data out using points. So you'd be surprised what you can put into linear form, by the way. And when you plot a variable, it doesn't necessarily have to be a single quantity. Notice this is not a single quantity. It's the doesn't matter. We can do that for each trial and find the different y's, quote unquote, for every trial. So in the next screencast, I'll show you how to do that in Excel. So we have two ways that we're going to find G, right? Two ways we can find G. Just calculating it and averaging them, and then this awesome cool method here using a best fit line. My fourth period class in the year 2016-2017, who has been witnessing this awesome piece of education, would now like to say hello to you.